Hello, everyone. I'm Larry Wilson. I'm a solutions engineer for Neox Networks. I cover North America for their products. Also joining me today is Philip Lorenz, is my peer. He's based in Germany,
Hello, everyone.
and he covers the rest of the planet. So uh, thanks for joining us today. We want to be very concise and brief, but we'll dig into it. So what we're going to cover today is kind of the agenda of, why do you do capture? What are the best practices? We're going to do a demo and workshop, and then a Q&A. And then we're going to talk about the next steps if you have some interest in these products. We're also going to be giving away a prize. We're going to have a drone we're giving away. You've got to stay to the end. Be from the industry, relevant, and have a valid work contact where we can contact you, the winner, to advise them that they have won a prize. So with that, we'll dig into it. So why is packet capture important? For forensic investigation incident responses, it's more or less the kind of the end-all solution. So it offers an indestructible record. It's allowing you to see exactly what occurred on the network, with packets, with latency, with everything that happens in your network and what data was compromised during a security breach. So, you have a lot of tools that are telling you things about the network, whether it's SIM or NDR or what have you. But if you really want to dig into the root cause of a lot of issues, it's not going to give you that information. It's going to give you a lot of logging and maybe some metadata, but digging into the real packet is very important. So that deep dive is what's going to help you pinpoint root causes of issues. So you have the network guy and the application guy, and they're arguing about where the problem exists. Is it the application? Is it the network? And Philip's going to give you a good demo of looking at that and kind of understanding what's occurring. Again, you can dig into the malware analysis threat detection. It's going to have all that information there for you. And regarding compliance legal evidence, it's going to give you proof of things. So if you have some legal issues or compliance issues, you're going to be able to have definitive proof of what occurred on your network and what happened. Also, if you're implementing a security measure, you can look into the packets, make sure that those policies are being applied correctly and functioning properly. So the implementation of packet capture is very important. You can use Wireshark. You have a laptop and you can grab some packets, but it's limited. And when you start getting to higher line rates, you really need to do it in hardware. So we can do packet captures at lossless packet capture at 100 gig, up to 100 gigs. And we have a lot of solutions that are tailored for specific line rates and data retention storage periods. And it is lossless capture. So that's the implementation we have done. You can't get to 100 gigs with software without doing multiple servers and an increased expense. We also have a lot of this ability to make storage and capture very efficient. So we can apply hardware and software filters to define captures of interest. So if you have certain IPs, certain client servers you want to capture, we can accommodate that. We can also do packet slicing to conserve storage space and compression as well. So once you capture these packets, what do you do with them? That's where all of our appliances come with a built-in software there's no additional licensing fee. And, one thing that's very powerful, it allows you to do forensic searches. So it gives you easy access to the data and events that occurred on your network. It gives you expert views of client server flows, applications that are occurring in your network. The compass function that Philip's going to demonstrate, it gives you a quick graphical view of what's occurring, in the network. If you want to map different graphs and charts, you can produce those very easily within the solution. So at a wide array. So there in the product line, there's a Packet Falcon and Packet Grizzly, and I'll talk about very briefly. So we have some portable devices. These are really intended for troubleshooting. Like, if you're moving things around, you're having a problem somewhere, you can bring these devices in. We have very small, compact units, the Falcon Mini, up to the portable, which has a built-in screen, everything you need. And when you start talking about enterprise-grade solutions, we move up into the rack mount units, and we have we can go up to 8 petabytes of storage at 100, and capture at 100 gig. And this scales really well for carrier enterprise solutions. So this is the Packet Grizzly. That's our larger appliances that accommodate those solutions. With that, I'm going to hand it over to Philip. He's going to do a quick demo for us and give you some insight into exactly how this works. Take it away, Philip.
Thank you very much, Larry. So yeah, thank you guys for attending to and being here. So what I want to show you today is basically how that forensic approach does work here, how we are going to access the data and what can we do with it, how can we identify problems fast or identify if something that comes up is really a problem. I mean, what Larry already said is that the most important thing is that we first capture something, right? So we set up everything nice and clean, and we make sure that everything is written to disk first. We want that pipeline from the packet arriving to our appliance and then being written to disk to be as fast and as uninterrupted as possible. This is why most of that happens in hardware and only goes to the memory. We don't want to involve the CPU too much. And then if everything is written to disk, we can start grabbing these packets and making them available for the analysis and checking problems. An important thing, of course, is that as we're dealing with more and more data with faster links, is that we have hardware that scales with that we can make sure that all that data is written to disk and that we also are able to analyze all of that data. And I know that like having millions and billions of packets is like a lot to look at, and no one can really do that. So there's like the use case most of the times is that you get a problem from somewhere and then you are assigned to that problem and someone says, hey, you got to check that out, you got to make sure that we know why this and that happens. And this is then where you start digging, and this is where you can, of course, if you have captured the data, if you have something running that captures your traffic, you can just go back and check that time frame, check the application, whatever is like that ticket that come up or someone that's talking to you is telling you what happened there. So this is why the first thing I would advise in that case is start asking questions, because as you see here, we have a capture running that is not that high of a data rate. We have right now like 1 day, like 24 hours of traffic captured, and we have like already 76 million packets. The first thing you want to do is like getting to know the problem a bit better so you can pinpoint it, right? And then if you know what you're dealing with, like, is it a sporadic problem? And this is where it's really important that the capture is already running, because if you cannot like reproduce it, then you have to wait. Then you have to set up the capture and then wait for it to reappear, and that can take very long. And you also have to make sure that you have enough storage to like go back that far in time. This is where we can help you with, of course. So I want to jump to my capture forensics, and then I do what Larry already described, is hitting that forensic search button and basically running the already captured packets through my analysis engine, and then like pinpoint it by the start and end time, like when did it happen. And I can also, of course, filter that down if I already know something, like is it a problem with a specific application, and I can, for example, filter for that certain application, certain protocol, for an address range, anything that helps me like reducing the data that I have to look at. For the ease of it, of course, I already prepared something a bit, because I don't want you to look at the bar where it's running through the analysis, but for completeness, I analyzed 11 million packets, and it took the engine 1.5 minutes. So if I already have broken down it really well, and I've only like 100 packets to look at, and I only want to know like how they're distributed, is like the handshake working and stuff like that, I can of course already jump to my packet list, click on packets, then click on them, and like start looking at the packet decodes, seeing if everything works as it should. For example, I have an application that is expected to have certain fields set, and it doesn't. Then of course this is something I can pinpoint really easily, like just filtering for it, or filtering for the flow that I'm interested in, and seeing if the field is actually what I have. Where it gets a bit more complicated, of course, is when the problem is a bit more vague, right? Where someone says, my application is slow, or the network is really slow again today. This is where I usually start asking questions like, what were you doing when that happened? Was it only a specific application, or was it like different ones? Was it only with your browser, or I don't know, maybe you have some also in-house applications that also had problems. Then you can like start getting an idea if it's only internal or only external or everything, and if and starting to get to know the problem a bit better. What I like to do, if it's some application related problem, or if I don't know anything at all, I go through to my application list, and we have a DPI on our engine that recognizes, I think, close to or over 5,000 applications. And it helps me a bit. Maybe let's make it a bit bigger. That helps me, of course, understanding what the traffic is. So how does that list work? I have the list of applications, of course. I do see the number of flows, things like that, how many bytes were sent, how long the duration is. And I do see an average response time of the application. What I also like to enable to quickly compare that, if someone says something is slow, is to include the three-way handshake, because that gives me an idea of how fast the connection setup was. So when the connection setup was really fast and the average response time is slow, it looks like more of an application problem, but we can go into that a bit deeper in a second. And then what's also interesting a lot of times is that events row. What that events mean is that we have an expert system in our appliances that indicates possible problems for me. I say possible because, of course, how this works is it shows me things to look at inside a network. But things that I can look into inside a network are a lot, and like networks and also network protocols are designed to handle problems. What I mean with that is, only because I have some network retransmissions, so packets that are somewhere lost and then retransmitted, that doesn't mean I have a problem. This is just like, although networks get more and more reliable, it just happens, and protocols are designed to handle that. And as long as it does not happen too much, and also like the application also matters, right? There are applications that are not so sensitive to packet loss. Others are not so sensitive to latency. So maybe if I have a response time that is like 1 second in the beginning, but I'm just starting a download, and after that it goes smooth, I'm fine with waiting 1 second before the download starts. What I mean by that, context always matters, because if I have that and you see the numbers of events here, I can analyze for days and weeks, and I can analyze problems that are not really problems. So that's again why I encourage you to ask questions first. So for example, let's take that Outlook. application. What I can do now is if I elapse that, I do see all servers for Microsoft Outlook. So these are all public servers for that application. And if or maybe one thing that sticks out to me here is I do have pretty fast handshake timing, so sub 10 milliseconds. So before the comma it's seconds, so we're like talking 4, 5, 8 milliseconds. And then I do see the average response time, and I have one that sticks out a bit that is like 3 seconds response time. So 3 seconds response time, again, in context. If it's a download that waits like 3 seconds before it starts and then everything goes smooth, it's fine. But if it's like periodic requests and everything like takes 3 seconds until like a small chunk of it is loaded, this can really delay stuff. If I elapse that server, I get to the clients talking to this server. So I have that server with the 162 in the end, and I have 3 clients that talk to it. Some with more, some with less traffic on it, and the first one is seems to be the one with the long average response time. And if I elapse that, I get the flows. So this server and this client have 2 flows within that time frame that happened here. The first one is the one with the longest response time, and if I elapse that, I get another layer that tells me about these expert events. Let me make it a bit. Yeah, so we do see all of it. So what I see here is I have some events telling HTTP slow response time. This seems to be the case, of course, as we have a pretty long average response time. I see some a non-responsive client. Busy network or server is an interesting one because that means that the response time is like fluctuating, so it's like not always the same, and it goes up and down a bit, which seems like there's either the network or the server is busy right now. So I do have some indicators here that would make me at least a bit suspicious to look at that flow a bit closer. What I can do now is, of course, I can just go here and say, okay, select related packets, and now I have some things I can choose by, which is either get everything that Outlook is doing. This would be if I expect, for example, a problem with a certain application, then either client or server. Client would be the case if I say, okay, I'm now on the troubleshooting. I know that there's a problem, and now I want to see, okay, maybe the client or the server is having a really busy time. So I can now choose the traffic to see everything the client does and see if there's like a lot of things going on in parallel. And I can do the same thing for the server. Of course, given that I have a capture somewhere there close to the application, of course. I can do the same thing for only that client server connections. This would be then both of these flows here. And I can do the same thing for only the flow if I want to analyze that further. What I like to do is using the flow visualizer. The flow visualizer basically is a tool that helps me understand the flow a bit better. I can quickly jump to it. I already prepared that one. Because what that helps me do is going step by step through something like this big flow and analyze how it's behaving, although it is encrypted and I don't even know what's inside. But just by some, like, let's call it behavioral analysis, like what does the application do, what is like the order of it, I can make some educated guess. So what happens first in every connection is, of course, the network setup. Basically, it's the TCP handshake, right? So what I see here is I have a packet from the client, and here I see the flags. I hope it's big enough for everyone to see. I can make it a bit bigger. here I see the flag. So this is the S for the SYN flag. Then I have the XSYN, and I have the final ACK to finish the handshake. I always like to enable the delta time and the relative time. But from the relative time, as it starts by 0, I see, okay, this took like 9 milliseconds. And also interesting, maybe the delta time between the server ACK and the client ACK is way shorter, which basically means I'm most likely closer to the client than to the server. There's also other things like from the TCP headers or IP headers that can help me with educated guesses around that. Like the IP time to live field, for example, that tells me gives me an educated guess for that. Okay, so next thing that happens is the encryption setup. So the TLS handshake, we have the client hello here, then we have the server hello, some change of the cipher spec, all good. This should be the certificate. And then here it starts and says here we start with application data. So what usually happens, the first thing that happens is that the client sends some sort of request, because for some reason, of course, it did establish this connection. So now it will ask or it will tell the server why it did that. It will request something. One thing I didn't talk about yet is the length of that bar is basically also the length of the packet. So the longer that bar is, the more payload is inside that packet. So basically these first few packets, they didn't have any payload. This was just TCP header basically. And now we're getting some payload, and this of course should be the request. Although I don't know what's inside, but this is just how applications usually behave. And then what we usually get is that the server responds to that. But there's two different types of responses. And also the application helps me with that a bit, because you see that I clicked on that row here, and it highlighted it blue, and then it did highlight another line here in red. Basically what that does is it tells me, if I click on that line, which packets belong to that. So basically, if I click something that is just an acknowledgement, it will tell me which packets are acknowledged by that. And if I go down the line a bit, I see, okay, this packet here does not have any payload, and this seems to be the acknowledgement packet for my first few data packets, so for the request. And it does not have any data. So what that means is this is just the server's network level response. So this is basically the TCP stack of the server telling the client, hey, I got something from you. I'm working on it. Don't send it again. I got it. Okay. And now the server will do its internal computing before it can give back the response. And this is usually the next packet, right? So now the next packet comes and we have some data. And this is like, maybe there's something small first, and then this seems to be a larger chunk. So if we scroll down here, now we get data transferred. What is always interesting in these cases is which part of these two packets takes more time. So now that I have the request here, and I have the network response here, I need to calculate that time here. And I'm like here at 36 milliseconds. So this is like another 8 milliseconds. Guess what? This is basically what we had in the handshake also, right? So this is the network delay. Sorry. And now after that, I get a packet also from the server. So there's basically the same network delay inside. already. And now the delta time between these two packets tells me the application response time. And this is only 14 milliseconds. And 14 milliseconds usually is not that much. So it seems at this point, at least, the application is behaving pretty good. And now I can start scrolling through the application and see if something goes on. Right here, I don't see that there's like much requested. So maybe here something is requested again, but then I don't see much data transferred from the application afterwards. So it seems like maybe there's some upload or it's showing some stuff. But like that, I can analyze how the application behaves, and maybe I also have the guy submitting the ticket or someone that told me here's something going wrong. Telling me what he did, and then I can map that onto this ladder and understand how the application dealt with, for example, the clicks that he did and things like that. And of course, I also already scrolled through that and looked at some things. So I know I have to scroll pretty deep to get to that message again that we've seen before, and to that the cause of that huge delay. And here I'm getting that event, the HTTP slow response. And now we're at another episode of analyzing problems that are not problems. Although it seems like there's something really bad going on, because we have exactly that behavior. We have some packets from the coming from the client side. We have a really quick server response that takes us these around 8 milliseconds, and then the next packet takes me like 6.5 seconds. Wow, this now looks really bad, right? The thing that we have to keep in mind now is there's no data being transferred. And I see that behavior again and again. So there are some packets, then I get the acknowledged packet, nothing happens, and now it's 13 seconds. And the same thing again, now it's 6 seconds again, and so on. And the pattern is always the same. And this is a classical session keep alive, basically, right? So there's the client requested everything he wanted, the server gave him everything, and now from time to time the server is asking him, hey, do we still like need to have that connection running, or can I close it? And the client is saying, I'm not sure yet, maybe let's just keep it running. Maybe there will be an email coming in soon, as we're looking at Outlook, right? And then we have to sync again, and guess what? Something happens here again, and then we have the same behavior again, right? So we have the HTTP slow response time. It also seems like these 6.7 seconds and only 1.5, and then we have the 13 something. So seems like a pre-built pattern. But this is exactly how I would tackle things like that. If I have someone telling me, hey, I'm dealing with this application, I'm dealing with that server, I'm dealing with a slow network, I'm asking him, okay, what is exactly what you're doing? What exactly is slow? Is it always, or is it only sometimes? If it's only sometimes, when did it happen? Please, like, tell me and give me like, or document it the next time that happened. Give me the exact time frame, and then I will look at it. Or also tell me when it went right, and then I can compare that. It also a lot of times helps. But then I will look exactly at that and see, okay, is the network part of the server responding slow, or is it the client? If I want to investigate that further, and I know Larry promised you some charting. Give me another 5 minutes, please. So what I did here is, what I can do really well with that tool is just jumping in between. And I showed you that before, like when I was in the application view, I had that button like select related packets by, and what I did here is select related packets by flow ID. So what I did is I extracted exactly this one flow. So if I go to applications, I only have Microsoft Outlook, I only have that server, I only have that client, I extracted only that flow. So for example, I can export it and show it to someone if there's something bad going on, or to like help me not looking at stuff that doesn't need to be looked at. So I extracted that. And now I can use the compass tool, and I can, of course, also use that with a lot of flows and things like that. But this is basically my interactive graphing tool. What I can do here is I will tell it, okay, give me the average megabits per second of first everything, and then I can choose the application, or I can choose a VLAN, and it can help me graph that. For this example, what is maybe interesting is if I have a problem with the response time, I can graph that over time. And now I will see either a certain behavior, maybe at the busy time it went up and then it went down again. Then I have a good indicator of saying, okay, at that time something was happening, and then I can start looking at that time more. Maybe tell the application guys, please check if maybe the memory was high, if you have some monitoring of the system resources. They should have usually. Same goes for the network. Maybe I can look at switches. I can also check the utilization of the client from here or from the server in total, right? So I can isolate that and then graph that, or I can go back to my forensic search of the whole thing. But I can graph basically anything I want. And what I see here is this exact pattern of this like 6 and 13 milliseconds for the keep alives, right? So first it's 6 milliseconds, then it's these 13 milliseconds. But this is how I can approach these things. If I want to quickly go back, I have that full like 11 million forensic search here. I can do the same thing, of course, for that. I have the response time. Let's go back to megabits per second, because this is more interesting, because I can graph that now for other applications. So if I'm interested, how much traffic am I sending to the Amazon cloud? Guess what? I can do it from here, and when did I do it, right? If I want to search for that. And this is also how I can check for utilization problems. For example, how I'm doing it here is I have different links separated by VLANs. So I could check if a certain VLAN was fully occupied at a certain time. So now I have my VLAN 991 graphed here. And it seems like at some point it got high traffic. What I can do here is also zoom into the time domain, because what I'm seeing here now is like an average of 260 megabits per second, which is not that much if I have a 1 gig link. But let's zoom into it a bit more and look at the millisecond domain. And it might bring up what I'm expecting is that I have something going on in the millisecond domain. Okay, not that much actually, but I do have some what people like to call microburst. At least here, I can zoom in a bit further. What happens there is that on average scale, and also what the switch will tell you, everything looks fine. But switches are usually designed to like not buffer packets too much, right? They just get it and they should forward it pretty fast. And even if the link is only for a few milliseconds on full utilization, you see that here. And if I have like patterns that like always go to that 1 gig and then down a bit, and then to that 1 gig again, and down a bit, and to the 1 gig again, then switches can drop packets. And this is also how I can check or investigate problems like packet loss further, to find where the problem might be. So these symptoms are always leading me to something, and then I can maybe talk to the switch guys, tell me from the interface counters if there were any packet drops on that, and things like that. So this helps me a lot. pinpointing problems. So for now, this is all I got. So I would hand back over to Larry. And of course, if you do have anything to ask, then please go for it.
Yes, thank you, Philip. I appreciate that very insightful demo. We do have some time for Q&A. If there are any questions that anyone has, please enter those in the chat window, and we will get to an answer. So we have a question that came in. Do we support 100 gig capture? The answer to that is yes. So we, Philip, I believe we can do up to 200 gig in a single appliance. Is that correct?
I mean, that always like depends on a few parameters. Like only the bit rate is not everything of it. It also comes a bit to like the packets per second, and then also the number of flows sometimes, because that's how this is load balanced. But yes, and the important thing about 100G is that we can really do 100G sustained capture. So not only for like small peaks and then we buffer it and hope that it goes down again fast. So we can really do 100 gig sustained capture.
Thank you. Another question that came in is, what is the best practice for how long to capture? I think that's another variable that, is a bit of a little bit of an engineering exercise, but can you expand on that a little?
Yeah. So how long to capture? Of course, it depends a bit. So we do have customers that, like, for regulatory reasons, need to have their data stored for like 30 days and longer. But usually what I like to do in like troubleshooting environments, if I'm like only have like these captures running, and then if a ticket comes on and something happens and I have to investigate that, is like aim for like 3 or 4 days, because then if something happens Friday afternoon and no one's in the office anymore, then I can still troubleshoot that on Monday. And this always, of course, depends, like finding the storage for the data rate you have, because of course the retention time depends a lot on these two variables, right? You cannot just like send like 100 gig of data to like some gigabytes of storage and expect it to be like stored for days. But we can of course help you find the right storage size for your needs.
Okay, yeah, that makes sense. Thank you. Another question is, do we have any mobile capture products for field use? And the answer to that is very much so. I think the Mini X, the portable unit all fit that bill, and that's their intended use. Correct?
Yeah. And the beauty of it, I mean, the Mini and the Mini X are like small appliances that you can even fit in your backpack. So it's pretty easy to carry into the data center and get it hooked up. And the cool thing about them is also that they like have like a display and HDMI ports for hooking up a screen pretty fast, because I think, although no one wants to really like stay in the data center to look at the captures and troubleshoot from there, because it's like loud and cold, but still, like, you want to like set it up and be sure that it does its job, and like the right data is coming in, that you configured everything properly. And this is what these products, and also like our Packet Falcon Portable that comes with a screen and keyboard already built in, help you like just set it up quickly, make sure everything is configured the right way, then connect it to switch, go somewhere like warm and quiet, and then remotely connect to do your troubleshooting.
Exactly. And one thing to note is that the interface is the same on all of our capture appliances. So it's not like, you get different looks, views. It's all the same from a analysis
Sets,
perspective. Yeah. Okay. I think that is all the questions. And certainly feel free to reach out to Philip or I if you have any that come up later. But yeah.
Yeah, I think I think the next slide does also show that we don't only have the portfolio to do the capturing, but also like to access the data in the right way to be effective on your captures, right?
Yes, very much so. So we have a full line of network taps, network packet brokers, bypass switches that we can bring. If you have any issues getting the data to the capture appliance, we can accommodate that very easily. So a full line of products there.
Yes, and I mean we cannot like highlight too much how important also the data source for the capture is, because if you already lost the data like on a span port on a switch before you get it to your capture, it will give you another or way more problems on analyzing the data, because if like a packet is missing and you're not sure if you lost it really on your network or on your monitoring pipeline, then this will give you a lot of headaches. So it's really important to care about where the packet came from and how you captured it.
Yeah, absolutely. Yeah, that's important. But if anybody has any questions, wants a demo or wants to contact us, you can scan the QR code here or hit our website, and we'll be glad to answer that for you.
Exactly.
So thank you for attending. I hope this was useful for a lot of you. And again, don't hesitate to reach out if we can help.